Sorry?
I didn't do it.
This is the first one we're doing. Doctor is through. Who else? Who else is through? I'm done. Nurse. Okay. And let's do it together. I've seen 3 different answers. So we must do it together. Maybe if we do this one, I give another one. I'm seeing different answers. Another different answer. My God. Your own must be different. God. See, let's first analyze the clockwise code. Let's analyze the forces that are clockwise and anti-clockwise. Let's check, please. All these distances, if you put your eyes on the distance, you might get confused. Where your eyes should be is on the forces. So we have to free body diagram. Come and do free body diagram. And see a force here. Ignore the distances. Just draw free body diagram so that you see all your forces. I'm seeing force here. Seeing another force here. Then I'm seeing pivots somewhere. I'm seeing force. So after this one, I give you one to use this principle and solve for me. Please pay attention. I'm seeing another force. Then seeing force. Is it out there?
Yes.
Am I seeing another force? Just the children. Let's start with this first one. If this thing is going towards these pivots, notice the direction. Sometimes they will not even give you direction. So once you see it up or down, you now know that you're pointing it towards the pivot if there's no direction. So I'll point this towards this side because there's pivots here. So with that principle, let's do. If this move this way, you see a clockwise and anti-clockwise movement. It's what? Anti-clockwise. The one that says anti-clockwise. So W equals to an ACW. Let's just write it down. And we know that anti-clockwise moves this way. So you are correct. Now let's move to the 5 Newton, the one that has 5 Newton. If this thing moves towards these people, notice that it will go like this.
Yes.
Maybe? Yes. And which force, which direction, which moment goes to? Clockwise, right?
Yes.
So, 5 Newton is under clockwise. Then W is under ACW. That is anti-clockwise moment. Now let's go again. For the next one, which is this one, 2 Newton. If this thing move towards this pivot, it will go like this. Yes. And which force goes this way?
Clockwise.
Clockwise, right? Because you see that this thing is the same thing. If you complete this, it's the same thing as saying. Yes. Chevy? Yes. So clockwise. So the 2 Newton goes to clockwise. Okay. Then for 5 Newton, since they are going down, it's the same thing. Chevy? Yes. This way. So clockwise. That means I have 5 Newton as well. This way. Now the minute so first thing is to always remember this principle. This principle, the first is to be force. Force this way and force this way. Or you say sum of all the forces must say force this way, which means the clockwise will carry plus, the anti-clockwise will carry minus. It's the same thing. But if you want to make it easy for yourself without getting confused, just do ACW equals to CW. Anti-clockwise equals to clockwise after finding it. So the next after finding this and this is to now ask yourself what are the distances. Now notice it. Okay, from 3, sorry, see, from W to this point is how many? Okay, we've not gotten, okay, so we've not gotten 3 Newton, shall we? That's this one. Okay, thank you. So let's analyze it now. If we're moving 3 Newton towards these pivots, is this clockwise and anti-clockwise? Is there any other force to make it? Is it like going down? If it goes down, it is of no use now. Our business is to find the direction it's moving as it's on these people. Do you know my see? Whatever here, the principle of moment is if we have something like a ruler, we balance it on the knife edge or pivot. It's trying to go like this. Go like this. In what direction would it? If there's a force this way, in what direction if it's acting downwards? Will it be trying to go down? If it's acting upwards, will it be trying to carry it up towards that pivot? I say it. That's what we are doing. That's the concept. So there is no need to show you that it's going down and going up. What we just need to get is the direction that that particular force will be moving us to, especially when it is angled this knife edge. So down or whatever, that's the direction we need. So I've gotten 3 Newton, I've gotten W, and they're fall under anti-clockwise. If this is 12, if this is 12, 11, so it's going anti-clockwise. If this is 12, 1, you see clockwise. So that what I know is the next thing I need to check is the distance. And we know that for whatever force I have, since we are taking 2 moments or under a number of forces, you will always be checking. Once the force is at 90 degrees, you must do force times distance. Somebody will want to ask me, what if the force is not at 90 degrees? We are getting there. When the force is not at 90 degrees, it's at any angle above 90. We're not treating tall. But when that force is at 0, it simply means, or in the center direction, it simply means that moment should be equal to 0. There's nothing like force, nothing. Now let's still continue. We'll put all these things I'm saying. So I have my distance here to be 1 meter. You see how meter we're saying there? Yes. Then from that point to this point I have 2.5, right? Yes. Check for me. Yes. And if I have 2.5, it simply means that from W to this point is going to be W times 1 plus 2.5. Yes. Shall we? Yes. I do for me. So the distance of this is going to be 1 plus 2.5. Then, yes, that's what it's going to be. Why the 5 Newton force? How many? Look at this. From this point to this point is what? 2.5, shall we? Yes. So the 5 Newton force is going to be multiplied by 2.5 meter. Okay. What of what 5? That's not where my eye is. You need to be looking at where our eye is. The 5 meter is not my business if there's no force there. I said it, so nobody should confuse me. That's one thing you must notice. You must be the point where no matter how the question is set, nobody can confuse you. Your eye is on whatever force it is. What is the distance from that force to the particular pivot, knife edge? And you need to understand this concept using, even you can test it on your own. You can go find that knife edge if possible. I think at a J they should be selling it. You place your ruler, then be watching how it's dangling. You can now place small stone or sand on it. Take it out, you can apply force, watching the movement. So you understand it better. Now, the next thing is this 2 Newton, shall we? Is it not good? Notice I'm going this way, and I've analyzed this one. Then I've analyzed this one. After finding the direction, the next one I should find is this one. This is what determines the force. So this force now, we know it's going this way. So what is the distance for this force? Is it 2.5? Yes. We need to be sure. Okay. This is really our 5 that you're asking comes to play. This is 5, shall we? Yes. So if I do 5, then notice that from this time to this side is 2.5, shall we? Yes. So 5 minus 2.5. So 2.5 is remaining for this. Somebody wants to ask me what over the unit. So 2.5 is remaining for this. So I have that 2.5 for this. So for my 2 Newton, I have 2.5. Okay. Then for the last, okay, yes, the second to the last one, this 5 Newton. If I'm analyzing this, I'm analyzing the forces towards this. Don't come and do plus. So towards this. So this 5 Newton now, what is the distance? It will be 1.5. So 1.5 plus this should be? Yes. So it will be 1.5 plus 2.5 meter, right? Now for the 3 Newton, we need to analyze. See that we are going towards this people, shall we? So you see what this three little will cover? It will cover 1 meter, 1.5, and 2.5, right?
Yes.
So this will cover 1 plus 1.5 plus 2.5 meter. Rita, are you following this now? Are you sure? They are pushing you from your position. Or is it the practical? Okay, so please, if you watch very well, we'll be able to balance all the forces, locate all the distances. Now, the next thing is to apply the concept of ACW must be equals to CW. If you don't want to use this concept, you can just say everything that is on the anti-clockwise, you come and be doing minus W, minus 3 Newton, and all the things carried, plus the clockwise code, everything equals to 0. You see that by the time you do this to cross equality sign, it will still give you the same thing. Are you aware? Hope you are aware. Yes. So that is why I don't like doing that thing. Please, I'm teaching. You see, you want to see me? Hold on. Just wait small, I'm coming. So see, once, just sit down, sit down. So you don't distract our voice. Just sit down. So that they continue to learn. Yes, yes. Don't worry, pay attention. Yes. It's not like I'm distracting them in the negative direction, but I want them to pay attention to what they're doing. Like I see, look for me. 1 plus 2.5, what do we have? 3.5. So I will now have that this is going to be W 3.5. And look for me. 1 meter plus 1.5 plus 5. Shall 5. So I have 3 Newton, and this is meter, shall So I'm going to have that this is going to give me 3 times 5. 15. So Newton meter, right? So that means from the anti-clockwise direction, I'm going to have to sum it up. I have 3.5 W plus 15 Newton meter. Please, whenever you are doing this thing, once you are using this principle of anti-clockwise equals to clockwise, no need putting minus for clockwise side. The only time you put minus for clockwise side is maybe you sum everything up in one direction. Then that's it, everything equals to 0. You now be saying clockwise has anti-clockwise has minus in it. But I don't like us doing that. It's stressful. Before you know it, somebody will confuse somebody. So let's keep it this way. You face me, finish. So then what I know is let's get for clockwise. Now we'll do 5 Newton times 2.5 is going to give us what? 12.5 Newton meter. Oh yeah, now do for me. 5 Newton times 2.5 or 2 Newton times 2.5. 5. Okay, 5. And it's going to be Newton meter, shall we? Yes. And do for me. 1.5 plus 2.5. 4. It's going to give us 20 Newton meter, shall we? Please, you see how agile it is? That's how I want everybody to be agile. So if I ask you, can I see? Is it equals to 12.5, shall we? Yes. Newton meter, yes, plus 5 Newton meter plus, someone says 32.5. I add everything this side. 7.5 Newton meter, shall we? This side is something. Now, remember something. Notice that we have W, shall we? So, see what we do. We will keep 3.5 for one side because notice that they are not the same units. So that's the importance of carrying this unit. So I have 3.5 W plus 15 Newton meter. Don't worry. I like making sure we don't skip a step. Reason being that some people, once they are reading, they forget this class. They are now facing their confusion below. Yes. So we want to make sure that we have confusion. So see, I now have 3.5 W. When this cross equality sign becomes minus, right? Yeah. So equals to 37.5 Newton meter minus 15 Newton meter. I am watching for me what we have. 22 points. But let's do it here. So I have 3.5 W is equals to 22.5 and it's in Newton meter. So at this point I can say let's make W solid the formula by dividing both sides by the coefficient. So divided by 3.5 divided by 3.5. So you see that this will cancel this. So W is equals to what? But please, I want us to know something. It's going to be what? Equals what? Before, see, first of all, before we carry this 3.5, this 3.5 that we got for W, where is that 3.5? All these things are meter, Shebi? Yeah. So let's put it, this is W, 3.5 meter W, 3.5 meter, 3.5 meter W. Hope you understand what I'm saying. That 3.5, see now, 1 plus 2.5 is enough from distance. Unit of distance is meter, right? 3.5, this thing is W 3.5 meter. So I need to come and put it here. 3.5 meter, 3.5 meter W, 3.5 meter W, so that I can do cancel. I see it. So that I can write it in Newton. But if it will confuse you, don't even put the unit box. That unit is important so that as you did not put unit while we are doing this thing, you might end up summing up even the W. Some people are like that. So then look for me. 22.5 divided by 10.5. What do we have? 6.43 Newton. So that will be my final answer. You got 6.43. Let me see. Sharp. It's very good. That means everybody's understanding this. I'll give you one to solve for me. Now, please remember I said that moment is simply force applied to a body at 90 degrees. So that is why we define it as the product of force and perpendicular distance. Don't confuse it with torque. I've seen some students that will tell you, for example, if you come and toss something, that is moment. No, it's not moment. That one is not torque. So the measure of a body, or should I say the measure of force applied to a body in circular motion, that one is torque. It makes no difference. Then we say that torque is simply two forces acting in opposite direction. We said that. Now let me give you what to solve for. And please, what you need to understand is, why I want you to understand this thing well is that if you fail to understand this thing we are doing, rotational motion is one kind. Because when I start doing moment of inertia, it's no longer going to be us solving mathematics. Unless that we'll be doing things like integration. We'll be doing, if the body is at the center, how do we find it? We do the integral, we now do this, divide the x. So you see, if you miss this thing now, it might be hard. So I want you to get this thing perfect. As we solve many questions, try and get it. So I want you to enter rotational motion proper and start talking about moment of inertia and the rest. You have no issue. Alright, now finally, let me play this one. Should I play this one? Let me not change much. Let's say now that what I have here is, let's say 2 kg. Hello? Let's say I have 2 kg here. And let's say I just have, maybe this one should not be 3. And yes, let's say I have this one to be 4 Newton. And then let's say I come and put here to be x meter. Now they ask you, please, in this question now, what you're doing for is find the value of x. Hello? Yes. So it's the same principle, but this time around, find me the value of x. So find me the value of x. This time around, we're not finding the value of x meter. The question about the will not even tell you if it's meter, but you will know it's meter because of the pattern. It's one direction, it's having position. So find me x. Find me the value of x. Find me the value of x. Please, if you are just coming and you don't understand compound pendulum, I've already posted the video on compound pendulum to the group. So go and check the group. Check the video I posted on compound pendulum. Take your time this night to watch it well so that you understand it. Please. We normally make those videos so that you don't feel confused or keep asking questions. Is in tutorials they impregnate you academically. Is in tutorial they breastfeed you with knowledge. Yes. No, don't worry. They understand that it has to do with academics. Yes. So find me the X meter. I want you to believe me that if you're able to understand this momentum freedom of forces, once we enter the rotational motion, it will not even look like anything. We enter circular motion, we'll be wondering, we do momentum, do what, energy and power. On the 22nd or 24th, we go for Easter, for Christmas. Believe it though, we'll be here till 20-something. Today is 2nd of there. Normally we close our tutorial every year. We normally close around 22nd. So this year we are thinking of closing 24th. Yes. So that by January we start. Well, some of you by 24th, you won't miss school and finish. Can you get right? Yes. If you are doing just tell me, let me come and check that. If you are doing seminar, I'll come and check. So whoever can understand compounding, please watch the video. By tomorrow early in the morning, tomorrow is Thursday, right? Very early tomorrow morning, I'll still come early so that we'll do that use of uses of meter practical so that we learn it. I came very early today, I will do something. Tomorrow we'll still do that practical. Yes. So please try and comment tomorrow, the morning, so I'll do that practical. Those of you that work for practical, they give any other chapter. They give any chapter. The simple pendulum. Yeah. You know, how many will school in the simple pendulum? Medical students people are just enjoying it. Then, as physical biological science, what they are going through. Every day is a miracle for the physical biological science. Yes, they pray and fast so that they cancel their submission every day. If you are doing signal, just try, but I like how you're see. My man, never loud. It looks good, so you are correct. Dog. Excellent. Just imagine by the time you are entering exam hall this year, yeah, if you don't, there's next year, you will be full. That's what we say with pregnancy. Yes. Good shot. I think you might be correct. So we'll check.
Now please go.
Check. Use your initiative. Basically, let someone not stay here while I'm beginning.
Please.
You might be correct, so we'll solve it together. For your steps, yes. Good steps, but I'm not sure of the answer. So we'll solve the answer together. And you go. You hear one student collapse, crash, go for me.
Now please go.
Your steps, correct? We'll compare. Use two methods. And the two methods give you the same answer. You must be correct. We'll check. My friend, how are you now? You're not doing it. Okay, you entered late. Please, get the listen and let me get up so that you understand. We started around 2 now. Is it not 2 we started? We started around 2. We can't do physics for 1 hour. I'm coming. Okay. You might be correct. We'll check. No. Okay. Most people, everybody is having 58. No one is getting 58. Let's check now. Let's compare. If you like, just your work. Okay. Let's check. See, let's check. Do you know what's happening at that way? The minute I say everybody getting 58, they're including the answer. That's not that I see 58. But who see this step? Yes. See, now let's solve it together. Let's analyze. I told you the first thing you do is to make a free body diagram. So let's try to make a free body diagram of this.
Before you be free, to draw the free body diagram. Yes. You don't have the last question. How will you now draw the free diagram? Everything he saying is here. Get your goal written by him. Okay? Get your goal written. Some way around.
So you see how simple that this thing is looking. So gradually we are getting somewhere. See. Let's analyze this. First of all, what are the forces acting on this one? Let's check. Calm down. No fighting. See. Let's say this is my meter rule or a stand or a flat surface. What are the forces acting on this? I have the first one, which is 2 kg shading. But 2 kg is not a force, right? Yeah. So we need to always see that if we place this object here, the only thing that will make this object to balance is if the forces are equal. If it's not equal, it will continue to tend to the side that has more force. So for that reason, if I have mass here, this cannot be considered a force. So ask ourselves, any force acting in downward direction is having acceleration due to gravity to be G, which is a constant. So I can say F equals to mg. Or W equals to mg, this is weight. So I'll have 2 times 10. So people can do 9.8. And this will give you what? 20 liters, right? So this becomes the force I'm using here. So 20 Newton. Very important. Now up here I have 3 Newton, shall we? Then I have my all these things I put in, but you put it to make sure that you are correct. So I have my pivots or knife edge. Why am I putting this knife edge? To show everything complete. So the last thing I want you to think of, or like if you want to put yourself in trouble, once you go and, how should I say, put this distance, it will look confusing. So just make sure you draw the forces first. Now check, you could outline all the forces here. What would you miss anyone? So the next thing we need to take note of is the fact that if I have 12 here, going this way, always use this to remember it. Going this way is anti-clockwise. While if I have 12 here, going this way is clockwise. This is the way of God. So if I know this, I'll then ask myself, let's analyze the process. If this points towards this, because once this body is on the knife edge, everything should be happening, should be going towards maintaining the balance on this. Once it's not equal, it will just bend. Same thing here. So this force will be going towards this direction. And if you turn this now, what direction is this? Anti-clockwise, right? Yeah, so you see it's anti-clockwise. So I will go and put it under anti-clockwise. So 20 Newton is acting anti-clockwise. And 3 Newton, let's analyze the next one. When you do this thing over and over on your own, you become very fast. Okay, whatever. If you can have a problem. Once you okay, see what you do before 4 will come back. Because I know that you didn't send me yesterday, so you collect it for. She's in 200 level. I remember. I see. I have the next one. If this is moving towards this pivot, I should be having. Is it okay? Yeah. So these are the. If I analyze this, these are the forces. I should have the direction of the forces. So is this clockwise, should it? Yes. So let me just put 3 minutes under clockwise. So 3 minutes under clockwise. So 3 minutes under clockwise. Let's go. Let's go to the next force. If I analyze this one, to be acting this way, see that way. And what direction is this? Clockwise. What direction? Clockwise. So 2 Newton clockwise. So since 2 Newton is going down and it's going clockwise, that means 1 Newton should be clockwise. Let me analyze it. Now let's check for the 3 Newton. What about the 3 Newton? Clockwise. Going this way, though. Sorry. Going this one is. I'm moving this way, is anti-clockwise, yes. So 3 Newton is anti-clockwise. So the minute you are done with analyzing the direction, we need to remember that anti-clockwise moments must be equal to clockwise moments. So I write it out. Now the next thing I need to do is to now apply the principle of moment, which says that force and perpendicular distance. So I will ask myself, what are the forces acting on the anti-clockwise moment and what are the forces acting on the clockwise moment? Notice that for this 20 Newton, I have a force this way, which is 1 meter. Then I have another one to this point, which is 2.5. Is it not true? Shall we? So for this one now, simply look for me. 20 Newton times 1 plus 2.5 meter. 70. So this is going to give me 70 Newton. I analyze this one for me. Let's go on the second force, 3 Newton. From this end to this pivot, how many distance? How many? Yeah? Okay, it's not that one. Yes. This one, is it anti-clockwise? Yes. It's anti-clockwise, right? Yes. What about this one? Okay, this one is not clockwise, yes. And we'll put it there now. Okay, this one is anti-clockwise. Okay, what does it start with this one? No problem. See how we do it now. First of all, let's not have issues. Let's check something. This is 3 Newton, yeah. This one is 3 Newton, right? Is it in what direction? Clockwise. Okay, but what to do all the anti-clockwise? But if we start looking from the clockwise, then we might stress ourselves. So let's go on. After I'm done with this, let's do this one. After I'm done with this, let's do this one. Okay, but if you want this that way, no problem. See, this is 3 Newton anti-clockwise, shall we? Yeah. Anyhow you want it. And it's this one, right? Yeah. Okay. Now what is the distance? I have 1 meter, right? Yeah. Then I have X meter. Yes. Then I have what? 2.5. So it's going to be times 1 X. Right? So add it up, what do you have? You have 3.5 meter plus X meter. Yeah. Is it not true? Yeah. So we have 3.5 meter plus X meter. Is it not true? Yeah. Now, you notice that if I have 3 Newton on this, 3 Newton here. 10 Newton meter, shall we? Plus 3 Newton times X meter. 3x Newton meter, shall we? Alright, so let's go to the next one. So there will be no confusion. So the next one is 3 Newton. But normally if you're doing this anyhow, you know you will understand without confusing yourself. No problem. So this one now, clockwise. This one is going clockwise. And point the clockwise towards the pivot because that's the point everything is reacting on the center of gravity. So towards the center of gravity. If we point this now, what is the distance here from this point? 2.5, right? Come on, right now, 2.5 meter. I have 3 times 2.5 meter. 7.5 Newton meter. Is it that good? Let's go for the next one. 2 meters. Shall we? For the clockwise, let's clockwise. Shall we? Now what? From this point to this pivot is what? 2.5. Are you sure? Okay, yes. So this is okay. So I have 2.5 meters. I just hope everybody's following this thing. So 2 times 2.5 and 5 Newton meter. I am 4. Okay, yes. So this is 4 Newton. Yes. So from 4 Newton to this point of our center of gravity is going to be X meter, shall we? Yes. Plus 2.5, right? Yes. So X meter plus 2.5 meter. That means that this will go 4 times X meter will give me 4x Newton meter. Then plus 4 times 2.5. 10, right? So I will get 10 Newton meter. So I have 4 Newton into this. So now that I've gotten my clockwise and my anti-clockwise, the next thing I need to do is to sum up the clockwise moments, sum up the anti-clockwise moments in units. So now let's sum up. So we do 70 Newton meter plus, what did we get for this one? 3. Okay, this is where I have to show you. plus
10.5
10.5 Newton meter, then plus 3x Newton meter. Is it not good?
Yes.
My watch for me, what do you have? 80.5 Newton meter plus 3x Newton meter, should we?
Yeah.
So we have 80.5
Newton
Newton
meter
meter
plus
plus
3x.
3x Newton meter. You see something correct 3x, no problem. You don't want to be putting this Newton meter, it's not like that. But we are just putting it because we are teaching you. That unit that we are putting is not Newton, we just have to put it. Equals to, now, some of the clockwise moments.
2.5.
Okay, you are doing 75.
7.5.
Is it 7.5? Yo. Okay, 7.5 plus 5, shall we? What do you have? 7.5 plus 5. Then plus 4. Plus 10, sorry. 22.5. Okay, so I have 22.5 Newton meter, right? If you remember those days in secondary school when you did polynomials, is it not good? You come and do connect. Oh yeah, that's what I like that. 3x come here. You can have all x go here. So you see, if this one comes to point inside, you have equals to Newton meter, shall we? I see. 4x Newton meter minus 3x Newton meter. It will give you what, shall we? And 1 times this is 1 times x is x Newton. So now, please, those of you that when you are reading, normally confuse you the prayer, so you see all those solutions. I am for me 30.5 minus 58. Just 58. And wait, see. This is in Newton meter, right? This is in Newton, so 58 Newton meter. Okay, that means if we check it now, since I have x Newton meter and I have Newton meter here, so I can say divide both, anyway, no need. So let's just say since we don't know x, no need attaching this Newton meter to it. So x is simply 58 Newton, and I noticed everybody was getting 58.
Yes.
That means this cost is simple. Very simple. And the other was speak out. Okay, see. Somebody is asking me, how did I get x equal to 2.5 under this 4 Newton, Chevy? I check something. Chevy, this is 4. What are the distances? What is the distance when we are doing 4? Is everything here? Is it not good? Chevy? I noticed that the total distance from this end to this end is 5. Is it not good? And they give us somewhere to 2.5. So, what is varying from this end to this end is 2.5. Then plus, we have x meter. That's how we got it. What is the 58 what? Let's check. Is there something we carry that we're not supposed to carry? Is there anything to be like yes, because she's correct, so. Somebody say cancel the meeting. What are we using to cancel the meeting? Okay, we have 58 meters. No. We need to check. We are not doing imagination here. See. See now. We have 17 Newton meter here. 10.5 Newton meter. We are correct on the answers. We are checking why we have this. AX Newton meter. What? This is literally an interview. You cancel the two, you are left to just do it. How many cancel? Okay, see. We need to know how our head is got to that point now. I know mathematics students. See where we made. I think it's somewhere here we made that mistake. Are you sure? It's up to you to be checking where we added Newton meter. Is it up to you to be checking where we added Newton meter? Yes. No. So it's up to you. So I think what we can say is to simply say, see what we can actually say. If we really want to check it, we can actually say, let it to cancel it to Chevy. Is it not true? Right? And our value for x will not be equal to 58, right? So if we take x now to be 58, remember that this x, when we solve for this x, is a meter, right? Yes. So which means that our x in meter is going to be equal to 58. Just like that. So I think that's the next way to put it. It's not really a mathematical problem, but a logical one. Yes. Alright, please, the next one. Yes, next question. So I believe everything we've done so far so good is leading us to what we are looking for. And that is to get to the part where we start treating tall. Yes. And proper rotational Wait. State the conditions for A stable. Yes, B unstable. C neutral. Number C. In your secondary school days, they told you that you have two major types of equilibrium, Chevy. Which is what? Have you heard of thunder before? So, they are not too stable and unstable. Is that the word they use? This is not the word they use. It's a lie. They use static and dynamic equilibrium. Now, which is static and dynamic. Yes, but in most cases, what they are not teaching is just static. They are not using all these stable, unstable, and neutral ways, or should I say, ways to explain it to you. Yes, so please, when we talk about stable equilibrium, one thing that something is a stable equilibrium, it means that no matter the displacement, or no matter how you try to displace it, it's not easily displaced. For example, if I carry stone now, come and carry stone and keep here. Or let me use a perfect example. Let's not use stone, that one is too. It's too obvious. Let's use an example, right? Let's say I'm seeing this knife edge here. If I give this knife edge this way, now here, you see that it is balanced, you see that too? Very balanced, right? What of the situation where I come and carry this knife edge now? Keep like this. Like on the ground, for the mount now, to face the ground. It's not, is it possible? No. Shall you see it will be very hard, highly hard. Too hard for it to balance. Now, out of the situation where I come now, I say this knife edge, I keep it this way on the ground. You will see that at some point, it will just, what I will end up having is something that goes this way. You come and be in this position. More like, you see that it will tend to rest on the floor. Shall we? Yes, this is the position I will have. So you see that when you want to judge this now, for the fact when the displacement, if you want to displace this now, it will be hard for it to jump. So the displacement is hard. Now, when slightly is easy to displace, because if you keep this, it will maintain this falling position. So it's slightly easy to displace. And when this is what we call neutral. But when you notice that the equilibrium itself is hard to even maintain at all, any slight displacement causes it to move out of position instead of it is unstable. Are you seeing it? Yes. Another example, another perfect example is, let's say I have my pole. I want to clean this. So they now asked us, according to the question, they now asked us what are the conditions for that stable, unstable, and neutral equilibrium. So the first condition, you can write, the first condition for stable equilibrium, so the first condition for stable equilibrium is resultant force. For stable equilibrium, resultant forces. For stable equilibrium, resultant force is equal to 0. So for stable equilibrium, resultant forces equals 0. Or you say resultant forces causes no net displacement. Causes no net displacement. Resultant forces causes no net displacement. That is for stable equilibrium. Resultant forces. So no matter the force you apply, if it is stable equilibrium, it will not have any displacement. I know that displacement simply talks about change in position. Why for unstable equilibrium, resultant force causes a new displacement, or you say causes change in position of objects. That is for unstable equilibrium. Resultant force or application of force. I don't want to use application of force. I want to use the physics word, which we normally use as resultant force. Or you say net force. Net forces bring about new change or completely new displacement. Net forces bring about new change in position. Bring about change in position. Now for stable equilibrium, stable equilibrium, am I too fast? Yes. I said resultant force, or I say net force, causes change in position, or I say causes the object to attain new displacement. Unstable. For stable, there is no change now. I said stable equilibrium, resultant force causes 0 displacement. Now, please, for neutral equilibrium, so that's where we are. For neutral equilibrium, resultant forces bring about slight change in displacement. Resultant force bring about slight change in displacement. Basically, you are not even writing. It is short. There's no disability. Spiritual. So bring about slight change in displacement. That is one. That is one. As the resultant force bring about slight change in displacement. Resultant force bring about slight change in displacement. Now see. which one? Okay, you're saying this one is stable. So which one is unstable then? Z. This one is unstable. What about alright, so please, under the conditions for static and dynamic equilibrium, I want us to continue writing. So number 2. So under the conditions, number 2. See, we've given you the first one and for I gave you for stable equilibrium, neutral equilibrium, and unstable equilibrium. Now I'm saying under the 2 types of equilibrium, which is static and dynamic equilibrium, I'm telling you to write. So conditions for static and dynamic equilibrium. So in as much as they didn't ask it, I feel like it's not that I remember it. Let's talk about it. Conditions for static and dynamic equilibrium. 1. For dynamic equilibrium, for dynamic equilibrium to be attained, velocity must be constant. Or you say velocity must be steady. Velocity must be steady. You know that dynamic means kinetic, it has to do with something that is moving. So for dynamic equilibrium to be achieved, velocity has to be 0, or you say it has to be stable. Let's not use zero, it has to be stable, it has to be constant. I'm going to say that, and we know that at constant velocity, what happens? Acceleration is 0. So whenever we talk about dynamic equilibrium, the simply means that we cannot have acceleration around it. We must have a situation where acceleration is 0. So if acceleration, what we progress with the question, if we have any question or any situation whereby acceleration or retardation is going on that body, there can never be something like dynamic equilibrium. So for it to be dynamic equilibrium, it must have constant velocity. Have you taken that? Yes. Alright, for static equilibrium to be attained or to be achieved, for static equilibrium to be achieved, any question? Okay, so for static equilibrium to be achieved, the net moments must be equal to 0. The net forces or my net moment must be equal to 0, which is all these things we will solve. So for static equilibrium to be achieved, the net forces, net moments must be equal to 0. I have noticed sometimes when students are reading their textbook, what is moment? They dwell on that conditions for moments for force equilibrium of forces. They will come and be reading moments about this axis must be equal to 0. All those things you are reading is not what they are asking you. They are just giving you those things for you to be able to solve question. Once I see a question on moment, my focus should be on I look at the left hand side, make it to be equal to the right hand side, which is all the things we've done here. If it has to do with forces, equilibrium of forces, I look at the forces on the vertical axis, make it to be equal to the forces downwards on the vertical axis. I look at the forces on the horizontal axis, make it to be, or what is on the left hand side, negative x to be equal to what is on the positive x. That is just what they are trying to tell you with all these things. So with that said, we now understand that for static equilibrium to be achieved, net forces and net moments must be equal to what? So which is the same as saying that anti-clockwise moments, anti-clockwise forces must equal to clockwise forces or clockwise moments. Alright, read the next question. Read out the next question. List the types of, okay, it's just what I explained now. Static and dynamic equilibrium. You say static and kinetic equilibrium. Anytime you see dynamic, it's talking about kinetic. But I give you the next one. Okay, state conditions for parallel and what? Read this thing like what I mean. State conditions for parallel. Okay, parallel equilibrium. Yes, they are not parallel. equilibrium. You see what you have there? Okay. So please, what we are doing today, if you are able to answer all the questions on that PDF, believe you me, if you like, go to Canada, Jamaica, and come back. We'll be able to cover everything that has to do with equilibrium of forces and moments. Yes. So that we now move to, as we progress, move to rotational motion. Now, thank God, are you feeling the word? See, for parallel equilibrium, first of all, should you know that anything that has to do with parallel, for example, if I have this, I have this, and these parallel forces, is it parallel? Now, for us to have parallel equilibrium, for parallel equilibrium to be achieved, we need to know that the resultant equilibrium or the resultant forces, since they are talking about equilibrium and it's forces we are dealing with. So for us to have parallel equilibrium, the condition is that all the net forces on every parallel axis must be summed up. So just the way we do clockwise moment, we'll come and do clockwise moment. If we have something going up like this, we have something going up like this, these are parallel forces, are you aware? And notice that by the time we check and see that it's clockwise or anti-clockwise, we normally sum up everything on that axis. Is it not true? Yes. So for everything parallel forces, it must be summed up. So the next resultant forces must be equal to, let's say, the opposite resultant forces, which is anti-clockwise. So in simple terms, just say for parallel forces to have equilibrium, the forces on an axis must be summed up. So for us to achieve equilibrium using parallel forces, the forces on a particular axis must be summed up. So for us to achieve parallel equilibrium, the forces on a particular axis must be summed up. So this thing is more like we are giving you all those steps that we use in solving the question. But now we are treating it as a theory. So for us to have parallel equilibrium, forces on a particular axis must be summed up. We say for us to have parallel equilibrium, the resultant forces on an axis must be summed up. So if, for example, see, if let's say I have this to be my meter rule, and I have this, I have something of this nature. Let's say I have this to be my knife edge. By the time I check this and I see that it's a clockwise force, check this and see that it's a clockwise force. For me to even do anything and start comparing all those principles of equilibrium and moments, I must sum up the clockwise moments. Is it not true? Yes. And if I have something of this nature, I have something of this nature. Let's say I have this, let's say I have this. For me to even do anything about applying all those principles, I must first of all say, okay, is this anti-clockwise? Is this anti-clockwise? If yes, I must sum up the forces on this axis before I now do equal to. So it is different from forces on anti-clockwise and clockwise must be equal. No, this one is actually trying to tell you the condition of parallel forces is that whatever force is found on any axis must be summed up. Which is what we did so far, so good. All those are examples. Why for non-parallel coplanar equilibrium? If I hear non-planar, or sorry, coplanar, I simply know that it's talking about something of this nature. Is it not true? Yes. So the condition is that first of all, there must be concurrence. By concurrence, we mean that there must be at a point. Notice that if we have forces, let's say I normally come and see, that time we did vector. We'll come and do this force going this way, this force going this way, this one going this way, this one going this way. I notice that everything we are doing is always at a point in the origin. You see that? So the condition, if it's not to you, pay attention, observe it. If we see 5 Newton here, 2 Newton here, 3 Newton here, 4 Newton here, whatever it is we are doing in all these questions we've been solving before now, you will notice that they're always emanating from this origin, these points. So we say that the condition for coplanar equilibrium is that they must be concurrent. They must meet at a point. They must meet at a point. That is one. They must be concurrent. They must meet at a point. For coplanar forces, they must meet at a point. And the second one, the second thing about coplanar forces is that the sum of forces in the anti-clockwise direction must be equal to the forces in the clockwise direction. We are used to this, is it not true? Clockwise equals to anti-clockwise. Yes. So the sum of forces in the anti-clockwise must be equal to the sum of forces in the clockwise. Is it formation? Okay, I said first of all they must be concurrent. That means they must have a meeting point. Now I said the sum of forces in the the anti-clockwise direction, or you say the anti-clockwise forces, or you say anti-clockwise moment in general. But when I'm talking about equilibrium, I don't like using moment because it's not only moments that we have experiencing equilibrium. Even thought experiences equilibrium. So and all this is doing use of the principle of equilibrium and forces. So I said the sum of forces in the anti-clockwise direction was equal to the sum of forces in the clockwise direction. So if I know this, these are the conditions for non-parallel planar equilibrium. These are the major words that all the calculations you will be doing center around. My president, I greet you. Long time. So these are the conditions that are very important for you solving any question. So you can still go and make your own research. But these ones are very important that once we are solving anything, we must be revolving around it. So give me the next question. Give me the next one. Mega. Well, let's see. Give me now. I'm going to do that. Okay, one of these ones should be. So let me see. Let's see an example that looks like this for planar forces. If we solve it, we can now go. So let's check for anyone. Just keep it on your own. Check for just another video. Check for one that looks like all this for planar forces. And which one do you want us to solve? Number 8. Yeah. And once we finish solving number 8, we can now go. And pay attention. Once we solve number 8, we go. Once we solve number 8, we go. You can't say number 8. Don't worry. Are you sure? Yes. Okay. Tomorrow is Thursday, right? Please remember I said that tomorrow in the morning we are going to be teaching our practical on uses of meter at our B. 7:30 I will be there. Just like today, we'll start. Okay. So anytime we start on this question, tomorrow we'll complete it. Okay, in the question, they ask us, see what they're asking us here. They ask us to determine the tension in chord AB. See, they say we should determine the tension in chord AB. The T here. So let's call it TAB. Let me not put this in for people that don't like confusion. So let's use TAB, the chord here. TAB. So tension in AB. They also ask us to determine the tension in AB. So let's say this is TAB. Yes. For equilibrium of the 12 kg block. Okay. Thank you. So please, once we finish all this one, go. Tomorrow's tutorial class, when we come, we'll start from the questions with the no problem. Please, all the questions of that PDF, you must solve it together in this class. Because those questions are sometimes, if you don't do it, you might miss the foundation. Because I don't want us to enter rotation and circular motion without us being sure of ourselves. If not, we don't even have to solve anything. Yes. I see. Pay attention, please. I'll be teaching you two methods. There's one we call the man method. Or first the normal method. See, if I want to do this, I'll first draw the free body diagram. Yes, now students say we should start with 7 before 8. Watch. See, pay attention. Don't panic. Hope you know that everything has X and Y axis, right? Yeah. Why I even agree to start with number 7 is that I know you people. Yes, especially now that you want to go home. So I want to start with that one that we enter here. And this is 30 degrees, Shebi. Now I have 12 kg, and the force that will be acting down here, when you enter mass, what my distance is with is the forces. Are you alright? So to get the force, then I'll simply say gravity is constant. So F is W solid, which is equal to mg, which is 12 times 10 is what? So this force is actually, there's a force here, which is 120 Newton. C. Now, they did not give me anything here. They did not give me whether it's E or D or Shebi. And I have B. So what I'll say is this side is always minus x, this side is always plus x. This side is always plus y. This side is always minus y. But minus y has 120 Newton. So in equilibrium of forces, once you see this thing is not having just it's not having any extra, having those only horizontal. Look at what you are treating here. Equilibrium of forces. So in this case, we apply the principle of sum of forces in the horizontal axis. Treat horizontal axis, then treat vertical axis. So I will say on the x-axis, what are the forces on the x-axis? So E sub x, sum of forces on the x-axis will be equal to. On the negative side, that is this side, this particular part. But remember that we are not going to be using minus. What we just say is we'll just do, okay, let's do it that way, let's sum up. So on the negative axis we have the tension. The force here, the only force here is this tension, is it not? And this tension on AB. Are you aware? And since it's in the negative axis minus x, I will have minus TAB. I'm collecting all the forces, sum of forces on the x-axis. So once it's then we take the of forces. Now on the right hand side, I shall have plus because what I'm having here on this axis is a plus. This axis is axis of plus for x. Is it not good? This other one is for minus. Now I ask myself, there is no force here, but the only force here is actually this one that is acting on this road, A and B. Are you aware? And this A and B is on a component where it is not on x, it's not on y. So I can use vector. You remember I always call vector. And notice that this thing makes angle with the horizontal. Actually, it did not make angle with the horizontal. I will use the part that makes angle with the horizontal. Remember that our process. So carry this T now, bring it to x-axis, is going to the cos. Is it not good? So I have plus TAB cos 30 degrees. Is it not good? Everything is equal to 0. Do you know what this thing means? Why I did it this way is because naturally we are not seeing it clearly. But if you check it very well, you will now see that this thing is the same as saying this side is clockwise, Shebi. This side is anti-clockwise. You know, clockwise forces is equal to anti-clockwise forces, which is the same as saying, let's think this is clockwise. TAB cos 30 degrees. If this thing cross the quality side, it plus TAB. Is it not good? So clockwise forces is equal to anti-clockwise forces. That's the first thing, the first principle you need to do. But instead it will confuse you. Once you are doing this thing, you need to analyze this way. It will confuse you. Whichever one you want to use, but you need to be careful. So now that I've done this now, notice that at this point, TAB is equal to TAB cos 30, and TAB cos 30 is equal to TAB. Shebi? That is for forces on horizontal axis. Let's solve for forces on the vertical axis. We've got it for horizontal. Let's solve for vertical axis. So for vertical axis now, notice that down here, I have A here, Shebi. This is A now. Is it not true? So force on the rope is known as tension, right? So that means that this side, what I have here is actually TAC. Shebi, which means that sum of forces on the y-axis will be equal to up is positive. And remember that this thing belongs to nobody. So it belongs to both of them. So if I take this thing now to come to vertical axis, it becomes TAB sine 30 degrees. So sum of forces on the y-axis, I will have TAB sine 30 degrees. And I'm using positive because it's in positive y-axis. Now down here is minus y-axis. Is it not true? So minus, and here is 120, Shebi. Minus 120 Newton is equal to 0. Now see, this thing is the same thing as saying if this cross the quality side, so TAB sine 30 degrees is equal to 120 Newton. You see that too? So it's still the same thing. So that principle, thank God, this is now helping me explain all the things all the English I've been speaking. So you see, sum of forces in the upper axis is equal to sum of forces in the down axis. That's down vertical axis. Now let's go again. When I check something, if you look at this very well, it looks as if we can do something here. Because if I take the, if I divide both sides by sine 30, it looks as if I'll have 2 See that though? So we can say divide both sides sine 30 first of all. Do you remember that my principle? Which one is 30? This one should be? If I look like this side, should be? 1, then all over 2, which means I'll have 0.5. So 0.5, or we say, let's just do it this way. Divided by sine 30, let's not confuse you first. Then divided by sine 30, this will cancel this, should it? So TAB is simply equals to 120 divided by half, plus divided by 0.5. What do you have? 240. That person standing up, please sit down. You are blocking my video. Yes. And most people, that video is going to serve in this world. You don't see students inside hobby, and they see you. Academic, they want to give you the question. So what I said, the video is that they go and check and it's there. Everybody will rest. So please, I have what you have what? 240. Yes, okay. So TAB is equal to 240, and this is going to be in Newton. So I've been able to get TAB. Now, TAB is simply, remember, which part is my B? This part, TAB. So with this, now I'm able to get TAB to be equal to 240. But let's look again. On the x-axis, notice that TAB is equal to TAB plus 30, which means I can actually put this to now be decided as saying 240 plus 30 degrees is equal to TAB. Shall now do it for me. 240 plus 30 degrees is what? 207.84. So it's equal to TAD. Okay. That means this is approximately 208, shall we? In Newton. Because the TAD. Okay. Is there anything that asked us to find?
No.
Check the question. They just told us to find the tension in what? Let's just analyze it. They told us to find the tension in TAB, and tension in TAB is 0. So we've gotten TAB to be 240, and we've gotten TAB to be what? Please, this is approximately, no minus, approximately. This one is 208 in Newton. Now, please, I don't want to stress myself like this. Let's say this thing I find this student is someone Nigerian student. When I see, I don't copy this thing. I want to analyze this thing again. Copy, so that I can draw it. Let's not use the one method. Don't worry. Red oil. Let's analyze this. Can I explain? No. Okay, but I can do it. Let me check something. I have this, then I have this, then I have this. Sherry? Is this what I have? Yes. Please be checking it. Then I have, then here I have 30 degrees, Sherry? Yeah. 30 degrees. Okay, now please, if this is 30 degrees, do you remember that all the angles here is equal to 90 degrees? Sherry? So 30 plus 90 is what? 120 is equal? 120 degrees. Okay, let's check. Now, if that is the case, if this is 30 degrees, this side is 30 degrees. Remember that this is supposed to be 90, Sherry? Yeah. What is remaining here? 60 degrees, right? If this is 60 degrees, I want us to check. And this one is 90, Sherry? Yeah. So 90 plus 60 degrees, what will everything be? 150 degrees, is it true? Okay. So what is remaining here? 90 degrees, is it true? Okay, I just want us to check something. Okay. Okay. Now see, this particular, this is the tension, this is the line that gives us TAB. Yeah. Is it true? TAB. And notice that it is facing this angle. Shall we? It's facing this angle. Then, which other one did I ask also? This one and TAB, right? TAB. TAB is this line. TAB. Notice that it is facing this angle. And the whole of this angle, everything we got this angle to what? 120, right? But I want us to check something. Let's do sine 120 degrees all over TAB equals to sine. Okay, please finish this. Let's finish this side. Are you done? No. Copy. Be fast. Let's show this. How we need 12 kg times 10, should we go 120? Okay, so I can do it, right? No. What is holding us now? Okay, but I can bring this up part. This is the last one. Normally, physics is supposed to be, every physics class should be 3 hours. Yes. I see, notice, please watch. Notice, everything here is facing all the angles here. See that? See that everything here is facing all the angles here. And what are the angles? All the angles here is what? So let's do sine 150 degrees. All over the corresponding length, which is 120 Newton, is equals to, then let's see, when we did this one, we said that this is facing everything here. Is it not true? Yeah. So let's say sine, what we get is 120 degrees all over TAB is equals to then the next one is what? This one, shall we? And this one is facing everything here. Is it not true? Check. And we got into the 90. So sine 90 degrees all over TAB. This my formula is not scientifically proven, but it works. So let's check if what we are getting is going to. Now, please, what we are doing is now we're going to be doing just for this and for this. So we're going to do to find TAB. Let's do sine 90 degrees all over TAB. All those students that are saying what they want to say, you will soon be by class. All over 120 degrees. Please cross multiply to get TAB. So we then get that TAB is going to be TAB sine 150 degrees, shall we? Is equals to 120 degrees sine 90 degrees, right? Did it work? Yeah. Please clap. Clap. Okay, it's work. So if I divide this by sine 150, oh, you can put my head to nothing before me. My God. People like AI, you mean you say to see if it's possible. So Newton. And let's look for the next one, which is TAB. To find TAB. And when you're using the same principle, see if you can find TAB. So what this thing means is that I told you that everything physics. If you solve using one method and get an answer, and you've not used another method to prove it, and it comes when you must apply the right method, it simply means you are still deceiving yourself. Because for you to confirm your answer in physics, you must have so many means to prove that answer. Yes. So you use this one now, your assignment is using this same principle, find TAB body. Then if possible, you can even try the other question using this same principle. So we don't always have to use the first method to be stressing ourselves. Once you learn it, sign of this equals to the sign of this. So that method of using K to the number of forces is the normal method. But once you now learn it, you now start doing human method. You human know it. Alright, so please with this said, I want to believe I've been able to convince you. I want to convince you that yes. There is in tutorials, they're impregnating knowledge. So please, tomorrow in the morning, we are going to be doing physics practical of the at 7:30. Try and be there. If you want to be tired, just force yourself and be there. In fact, I want everybody now to be for those practicals. If possible, you can be doing everyone one practical. Everyone one practical. By the time we finish, we have lunch. So please let us start up and pray. If you are here, you're a new student, today is your first time. My number, I'll write it on the board. 780.
Verification start. After that,